Hello, good people. This is video number one of topic 4.3. And topic 4.3, in addition to related rates, which are topics 4.4 and 4.5, really go to the reason we study derivatives, right? We've been doing derivatives, we've been finding derivative values, but what exactly does that mean? And so now we get to actually apply those derivative skills into some contextual problems. And so in this video, I'm going to do a couple of these examples. We only have 6 of them here, but we'll do a few of them from each section, and then you'll kind of see the way we can put everything together: the skills of taking the derivative, of finding the derivative value, and then interpreting what that means. So we'll start with example number 1. Speedville High School opens its doors for students at 8 a.m. each morning. On one particular morning, the number of students inside Speedville High School can be modeled by the function p of t equals 25 times the natural log of 3t plus 1, where t is between 0 and 8 minutes, since the doors opened at 8 a.m. Find the rate that the number of students inside Speedville High School is changing at 8:03 a.m. Okay, so let's make sure we understand what we're given. We're given this formula, this function, and this function tells us the number of students inside t minutes since the doors open at 8 a.m. So you tell me how many minutes after 8 a.m. you're talking about, that moment, and this function is going to tell you how many people or students there are inside of the school. But it's only going to work for the first 8 minutes. Well, they want to know what's the rate of the number of students inside is changing at 8:03, so 3 minutes later. So this is here to tell us when we're going to investigate this rate. We're going to investigate this at T3. Why? Because T stands for the number of minutes since the doors opened at 8 a.m. This is 8:03, so that would be 3 minutes later. But I want to emphasize we're looking for the rate. So we're looking for a derivative. We're looking for the derivative of P. So we're going to find the derivative the way we normally find the derivative. So we have 25 times the natural log of 3t plus 1. 25 is a constant, so I can keep it there. And I'm going to multiply times whatever I get here. Well, the derivative of the natural log of something is 1 over something times the derivative of the something. So this is a chain rule right here. There's an inside function and an outside function. The derivative of the outside is 1 over x. Oh, but it's 1 over the inside function times the derivative of the inside function, which is 3. So in reality, this is 75 over 3t plus 1. This is what the derivative function is. But we want to find the derivative function at time 3. So therefore, p prime at 3 is going to be 75 divided by, let me go back to the other color, 75 divided by 3 times my t value, and my t value is 3. Okay, so then that is going to lead me to 75 over 10, which is 7.5. So now we get to figure out what are the units. Well, the units have to do with the units of the function, the quantity that this equation is measuring, which is the number of students. So students per whatever my input variable quantity is. So my input is time, and this time is measured in minutes. So we can say that the number of students inside the high school is changing. Specifically, it's increasing at a rate of 7.5 students per minute at time 3. But they just wanted us to find the rate. This is the rate. We don't have to explain what it represents or what it means. This is the answer. But notice we can put the units, and the units really tell us a lot about what type of answer we're getting. And that's it.